7. Remember that your homework tomorrow will be to work on tonight's assignment, plus seniors finish up your scholarship application. The deadline is tomorrow. Plus seniors work on your financial literacy. Okay, so the chain rule is a process that we use for taking the derivative of a certain type of problem. And that type of problem is a composition of functions. Do you remember what a composition of functions means? No? Okay, well good, I have a review down here. Okay, so composition of functions, or we say if a function is composed with another function. Do you remember or recognize that notation? Sometimes we say fog and golf. It's really read f of g, and that is read the same way, f of g of x. It's just two different notations that mean the same thing. And what it means is you are taking a function and subbing it into another function. So not taking a number and subbing it in, taking a whole function and subbing it in, just like we did when we found f of x plus h. That was composition of functions. Okay, so let's just drop down here to example 1. For f of x equals x cubed and g of x equals 1 plus x squared, find f of g and g of f. So would they be the same thing? Not necessarily, but occasionally they are. Okay, so go ahead. So this right here means take g and sub it into f. Okay, let me write out these functions again. Okay, so it means take g and sub that whole thing in the place of x in function f. Okay, so over here, when I do g of f, that means the exact opposite. It means take f and plug it into g. So if I have f of x equals x cubed and g of x equals 1 plus x squared, then g of f means take this whole thing and plug it in there. So do you see how they're opposites? Now, like I said, occasionally they will result in the same thing, but not often. Okay, so let's keep working this one out. If I sub all of this function in for x, then that means f of g of x will give me 1 plus x squared cubed. But over here, if I plug x cubed in the place of this, then g of f of x is 1 plus x cubed squared. Now, I could cube that out. I'd have to multiply it out 3 times, do a bunch of distributing, add up like terms. I think I'm going to leave that one. Over here, I would just get 1 plus x to the 5 or 6? 6. It's not going to be the same thing, is it? It will if I do this wrong, and I say 1 cubed is 1, and this cubed is x to the 6. But really, this means 3 of those. And that would give me something very different from that. I'd have a lot more terms involved. Okay, do y'all feel like filling that out? Because I don't. Question? Okay, so that's composition of functions. Yeah, I am. I'm just trying to show you that we're getting different things there and how you would sub it in. I hope so. I hope so. Okay, so let's do this one. F of g and g of f. Okay, so this one here means take g, plug it into f. So that means that whole x minus 1 will go in the place of this x. So f of g of x would be, go to function f, have a square root of x, but instead of x, I'm plugging in x minus 1. And that's it. Now, if I want g of f, then I'm taking f and plugging it into g. So this whole thing here gets subbed in here, and I have square root of x, then minus 1. Do you see the difference? Any questions? Okay, so when we take the derivative of the composition of functions, we must be sure to take the derivative of all functions present. The chain rule is what we use to do this. Okay, so this is really confusing looking. I'll go through it, but I think the best way to explain it is to work through some examples. So the derivative of the composition of functions, f of g, is given by, okay, so we want the derivative of f of g of x. Or it could be written like this. The derivative of f of g of x is f prime of g times g prime. Okay, there we go. That's the rule. Let me show you how it works. Okay, if I were to take this derivative, what do you think I'm going to do first? What have we been doing with square roots? Putting them in what form? If I were going to take the derivative of square root of x, how would I rewrite it?
Everything over x 1/2.
X to the 1/2, exactly. Okay, so if I see a square root, I'm going to use that same rule. So I'm just going to rewrite this function as 4x squared plus 1, but all of it's under square root. That means all of it's raised to the 1/2. Okay, so can you see that I have two functions here? Like one is there's a square root, but then the other function is 4x squared plus 1. So there is a function within a function. This function here is within this function of square root. Okay, so when I take the derivative of that, I have to take the derivative of all functions. So what I'm going to do first is think about this as something raised to the 1/2. Okay, so if my equation was something raised to the 1/2, how would I take that derivative? I would bring 1/2 down times that thing to the negative 1/2, correct? But then with chain rule, I'm going to also have to take the derivative of this thing. So I'm going to also multiply by the derivative of whatever that other function was. So I deal with one derivative at a time, but I tack on, using multiplication, the derivative of each function. Okay, so with this function over here, this is what the derivative would look like. The outer function here is that power of 1/2. The inner function is the 4x squared plus 1. I start with the outer function. So ignore this for now, and you just say like, okay, how would I take the derivative of something to the 1/2? I would bring 1/2 down in front, and then that power would be reduced to negative 1/2. So notice how I didn't change this at all. I just dealt with this exponent derivative. Bring the 1/2 down, subtract 1 from the exponent. Totally leaving that alone. Now I have to also take that derivative. So I will multiply by the derivative of this, which would be 8x plus 0. So that's why it's called the chain rule. It's like each piece of the derivative is tacked on like a little chain with multiplication. Now, often we can simplify these. For example, what is 1/2 times 8? 4. So I would rewrite this as 4x, and I'm just going to put that out front, times 4x squared plus 1 to the negative 1/2. Okay, can I distribute 4x here? Don't upset Aunt Sally. Please excuse my dear Aunt Sally. Order of operations. This stuff would have to be raised to the negative 1/2 before I could multiply this. So good news, we're not going to do that. The only other way that I might write this answer is leave the 4x, but drop this down, making that exponent positive. And then what's that the same as? A square root. Okay. Do you see how those two things are the same? So that's the chain rule. You take the derivative of each function one by one. Starting with the outer function, stopping when you get to the innermost function. Question on that example? Okay, let's look at this second one. Okay, this second example, example 4, is going to involve something else that we've talked about. I'm going to rewrite this as x cubed times 5x plus 2 raised to the 1/2. So I'm taking out that radical, changing it to a power of 1/2. Do you see that I have a product? It's this function times this one raised to the 1/2. Guess what I have to use when I have a product? The product rule. Okay, what's the product rule? UV prime plus U prime V. That's what we have to use. But within that, when I get to the V derivative, I have to use the chain rule. Alright, so there are rules within rules. Yes. Okay, so let's put a little U and a V over this. Okay, so there's our U and our V. So let's do product rule. Alright, so F prime of X. I'll use that because this was called F of X. Okay, so U V prime. Okay, so to take the derivative of V, I'm going to start with that outer function, that power of 1/2. So it comes down front. 5x plus 2 is now raised to the negative 1/2. But I have not taken the derivative of the 5x plus 2, so I'm going to multiply by that derivative, which is just 5. Okay, so this is U, and all of that is V prime. Plus U prime, 3x squared, times V. U prime V. I don't see a whole lot that I would change here. The only thing I might even suggest changing is just multiplying that 1/2 times 5 and making it a 5/2. I'll do that, but I'd be fine if you stopped at that step. Okay, so let's make this 5/2 x cubed times 5x plus 2 to the negative 1/2 plus 3x squared 5x plus 2 to the 1/2. Now, let me say this. If you don't like those exponents of 1/2, I could change that to a square root of 5x plus 2 in the denominator. And I could change that as just a square root. Okay? question? Not so bad? All right, let's try this next one. Find dy dx for y equals blah, blah, blah. All that stuff. Okay, so I see two different terms. So let's take them one by one. Dy dx. Okay, tell me what I would take care of first with this problem, with this term. Okay, I could distribute. That's an option. But I'd be multiplying 1 plus x cubed times 1 plus x cubed times 1 plus x cubed, and I'd have to do all that distributing, then take the derivative. I'd rather not, but that is an option. Okay, what's my other option? What would I do with an exponent of 3? Bring it down front. 3. And then that stuff is now squared because I subtracted 1 from the exponent. But I have not taken the derivative inside here, so I'm going to multiply. Derivative of 1 is 0. 3x squared is that derivative. That takes care of that whole first term. Brought the 3 down. That stuff is now raised to the 2. Multiply by the derivative inside the parentheses. Okay, let's do the same exact thing for this term. Whole new term, whole new derivative. I'm going to bring the 4 down in front. All that stuff is now raised to the 3. So I'm just dealing with one derivative at a time. But now I haven't taken the derivative inside, so I will multiply by 8x to the 7. Okay, so to clean this one up, let's multiply this times this and just put it out front. So that becomes 9x squared, 1 plus x cubed squared. And then over here, I would multiply the 4 and the 8x to the 7 and make that minus 32x to the 7, 2 plus x to the 8 cubed. And I would 100% leave it there. Question? Got it? Okay. I just have lots of praise for you on these. Okay, so this one's written a little bit differently. Y equals 2 plus square root of u, but then u equals x cubed plus 1. Alright, we'll follow the directions, and then I'll show you how else we can do this one. Find dy du. Okay, that means go to function y and take the derivative with respect to u. Okay, so dy du. First of all, I'm going to think about this as y equals 2 plus u to the 1/2. Now, dy du means take the derivative of this equation with respect to u. So that's easy. Derivative of 2 is 0. Derivative here is 1/2 u to the negative 1/2. And that's it. Okay, find du dx. So, whole new problem, but now we're going to this equation, find the derivative of u with respect to x. Well, that's 3x squared plus 0. And now, find dy dx. Okay, if I want to find dy dx, this equation y has u in it. So before I can do that, I've got to put this in the place of u. Because my equation of y doesn't have an x, but I can change that. Okay, so what I'm going to do before I take this derivative is I'm going to change this y to 2 plus square root. Now plug u in. Now I can take the derivative of equation y with respect to x. And I would probably do this. 2 plus x cubed plus 1 raised to the 1/2. Now I can take the derivative of y with respect to x. Okay, derivative of 2 is 0. What do I do here? I bring the 1/2 down in front. Don't change this stuff. I'm just dealing with that exponent of 1/2. Now take the derivative inside, 3x squared. So that's three totally different problems there. dy du, du dx, dy dx. Oh, right here, because I was taking the derivative of it, and derivative of 2 is 0. Any other questions? Yes. From the derivative of the inside. Any other questions? All right, let's try example 7. So y equals u squared plus 3u, and u is 5t plus minus 1, but we want to find dy dt. Y is not in terms of t, so we've got to make it in terms of t first. Okay, so let's plug this in the place. So all of these go here and here. So I'm going to totally rewrite the equation for y. Then I can take its derivative. 5t minus 1 squared minus 3 times 5t minus 1. Okay, this one isn't so bad if we want to distribute first and then take the derivative. Or do you want to just straight up take the derivative now? I think I might distribute. What do y'all think? I think it might be less trouble in the long run. Let's see. So 5t minus 1 squared means 5t minus 1 times 5t minus 1. I can distribute the 3 here, which is actually a negative 3. Then let's FOIL this out. 25t squared minus 5t minus 5t plus 1 minus 15t plus 3. Okay, y equals 25t squared. Okay, I have negative 5, negative 5, negative 15. What does that equal? Negative 25t. And then I have a 1 plus 3, which is 4. Okay, so that is my equation for y. Now I want to find dy dt. So that means find the derivative of y with respect to t. Now my equation is in terms of t. So this is 50t minus 25. So this variable in the denominator tells you what variable the equation should be in terms of. And if it's not in terms of it, you've got to change it before you take the derivative. Go ahead, Andrew. Any questions on that one? Alrighty, so we've got 4 more to get through. Ah, perfect. Okay. So we don't have to do any subbing on these. These are just straight up find the derivative. We will be using the chain rule and possibly quotient and product rule. Okay, find f prime of x for this function. Now, I don't know about you, but I don't want to multiply this thing out 6 times. So let's use our product rule. So this is u and v. How do I know when I have a product? Because I have something involving x times something involving x. Okay? It's just that simple. function of x times a function of x. Okay, so let's use our product rule. F prime of x is u times v prime. Okay, how would I take the derivative of 5x plus 4 raised to the 6? Talk to me. Bring the 6 down. And do I change the 5x plus 4? No. I'm not dealing with that yet. I can only deal with one function at a time. I am dealing with that power of 6. So I brought it down, changed it to a 5. Now I'm going to take the derivative of the inside, which is just 5. Okay, so that's u v prime plus u prime v. U v prime u prime v. Okay, I would not do anything over here. I would change this. 5 times 6 is 30. 30 times negative 3 is negative 90x out front. 5x plus 4 to the 5 minus 3, 5x plus 4 to the 6, and leave it at that. Questions? Okay, next one. Where would I start? Right? Where would I start? What rule would I start with? Do I do them both at the same time? No. Okay, so this is a product rule. Again, here's something with x multiplied by something with x. Okay, so if I start with u, then I'm actually not changing that first one. dy dx. U, just copy it. Bring u down. Times v prime. Okay, so now v does have an exponent that I will bring down in front. Times 2x plus 1, make that to the 4. But I didn't take the derivative inside yet, so now I will multiply by that derivative, which is just 2. So that's u, all that's v prime, plus u prime. Okay, what is u prime? Anybody want to help me out? If you're wrong, you're wrong. It's okay, we fix it. Bring down the 7. Keep the 3x minus 1. But do what with the exponent? Make it a 6. But I didn't take the derivative inside yet, so now I have to take care of that one. Okay, so this is, let me write this out. This was u. This was v prime plus u prime. And now I need times v. So times 2x plus 1 to the 5. Ooh, do we want to clean any of that up? There are just two things that I would really like to. I'd like to multiply that 5 times 2 and put it out front. And I'd like to multiply the 7 times 3 and put it out front. Can we do that? That's not too bad, is it? So this 5 times 2, and all of that's multiplied. So I can put that 10 just in front of all of that. That whole term. Doesn't that look a little bit cleaner? Okay, then this is all one term right here. So I'm going to put the 7 and the 3, 21 in front of that. And all of that is our derivative. Question. All right, 2 more, and I actually saved the easiest one for last. All right, so what about this next one? I see a fraction, and then I see it cubed. What would I start with? I will have to use the quotient rule, but I start with the outer function, which is the 3, the exponent. Okay, so differentiate. I'll call this g prime of x. I'm going to bring the 3 down. That whole fraction is untouched. It is now squared. Now I'm going to use your quotient rule because I have to take the derivative inside the parentheses, and inside the parentheses is a fraction. But I just tack it on with multiplication. So low d high minus high d low over the square of what's below. And you know what? I think I'll just leave that one right there. Okay, so we dealt with the 3. Don't touch the fraction, just deal with the 3, subtract 1. Then we deal with inside, which meant use the quotient rule. Okay, easiest one is last. I see a power of 204. Woo! How'd you like to do that? No, thank you. Okay, we're going to find the derivative of h, so we'll call that h prime of x. We're going to bring that power down, 204. Times all that junk. Raised to the what? 203. And then we're going to take the derivative inside, multiply it, so times 28x cubed plus 18x squared minus 1. We are done. Whew. On a scale of 1 to 10, how bad? 6? Okay, I can live with a 6. Okay, we're not at 9 or 10, so that's good. Okay, I'm going to stop the video here, but just as a reminder to our friends at home and to you guys, tomorrow you are working on this homework. Thursday we have a quiz after we go over this homework. Quizzes, you can use your notes. Tomorrow you will also wrap up scholarships, local scholarships if you haven't already done so, and work on that financial literacy. The deadline is approaching for that.